Good morning, ladies and gentlemen of calculus. Here we have our first assignment of the day. Multiple Monday. Find the following without the use of a calculator. How did you do this one?
I didn't do it because I was looking for it the whole time.
Oh, really?
Yeah,
Okay.
and Hannah just told me.
No, this one here is a separate thing. When it says multiple Monday, this is a separate thing I pull up that's not from your packet. All right. How did you look at this one?
Hold on.
What is in the, like, what's,
Okay, let me show you what it is here.
I can't read it.
The nth derivative of y is y. You have an n and y equals negative sign x, then y seventh. Okay, what it is this would be like y the first. This next one here would be like y prime, which would be the first derivative. The next one here would be like y double prime, which we're familiar with. So what you're doing is you're taking this derived like 7 times to get to something. So what it would be is this going to be like y to the y, that'd be first, yeah. So it'd be y
I figured you would. You kind of had like.
to the 7th here, right? Like 7 of these things here. So that'd be the nth derivative. So it'd be the 7th derivative of this. So what is that going to be? Okay, let's go look at this. We talked about this, right? You remember this?
Yeah, I remember that.
Okay, so derivative would be like this. First derivative. So,
Second derivative.
yeah, so anyway. So in this case, we're given like negative sign, right? And we're told 7. So if we make 7 cycles through here, where does that go? 1, 2, 3, 4, 5, 6, 7. So we get negative cosine. So that's going to be the same as what? That's going to be the same as the first derivative, right? So we should get, so it should actually be this one right here, which is like the first derivative dy dx. Does that make sense? So cycling through. Here, here. Does that make sense a little bit? So cycling through. So it's the same as the first derivative is what it amounts to. All right. And then if it had been y sixth, what would have been? Just y, right? Okay, let's go to the next one right here. Find dy dx if y equals 4 over x cubed. This one right here should be, you should easily be able to eliminate stuff for this too. In fact, just with elimination, that should be pretty easy without even putting a pencil to it. Because if you have x to the negative 3 power and take the first derivative of that, you're going to have what? X to the if you have x to the negative 3, 4x to the negative 3 power, the first derivative, is that going to be what did you get for this one?
Well, I did have it. I can't tell if my fraction should be angled or not. I don't know what I had to plug in.
What did you get?
I think it's C.
What did you get, C?
Is it? I think
What did you get, E?
It's either B or C.
I think it's C.
I think
I don't know how.
I think it's E. I'll see why.
Oh, you have to add it. Oh my god.
Because what we have is we have 4x, so negative 3 power. And you take the first derivative of this, you're going to have negative 12, x to negative 4 power.
I forgot to add it. I subtracted it.
With negative 12, x to the 4th, so it's E. Okay. That's not that hard, is it? You know how to do this, right? You know how to do this, don't you?
I got it.
Hannah, you know how to do this, right? Hannah,
I
you
wasn't thinking of
how to do this, don't you, Gavin? You can do it.
yeah, a little bit.
See, I
Okay,
didn't-
this should be stone cold easy. Okay, this is like the easiest type of problem you could have.
I keep taking one away instead of adding it. I don't
But
know.
that's one reason we're going over this, to review the things that are easy that we forget. All right. Here we have, use the table below to find the value of d dx of f times g. That looks like it's a multiplication at x equals 3. So look at that one for a minute. Let's see, it's going to be... Okay.
Is that 3 halves?
Yes, 3 halves down there below f prime of x, yeah. Where x equals 3, 3 halves.
It seems like a trick question.
All right. Do you want a hint on this one?
Yes, please.
Here's the hint. I worked it out in my mind. I'm not 100% sure I'm right. When I worked it out in my mind, I got C.
Oh, no,
That wasn't a hint, that was an answer.
No, it was an answer, because from that answer you go try, well, first of all, if I'm not 100% sure I got it right, I told you that, right? But I
Oh,
give that
wait.
to you so you can backwards, you could reverse engineer
Okay.
how that's a right answer.
Alright, hold on, because now I know what to do.
So I'm trying to get an aha out of you somehow.
Okay, yeah.
I got one out of Aaron.
Now that I understand the question.
Yeah, so he misunderstood the question, he says, a little bit.
Yeah, I was confused. Alright.
So he found out, so C is the right answer, is that right, Aaron?
Yes.
Anybody else find C to be the right answer or found out how it is? So how, you know how it is you know how it is a right answer, Hannah? Right, you know, Hannah, how it is a right answer?
Plug in, it's on the table. Can you stop?
Do you, Kylie, you know how that's a right answer?
No,
Aaron?
because it's not. It seems like a trick question, but my head. Hold
But
on.
it's one of these things that's reaching back to
Okay.
things we did last semester, which is quite some time ago. Okay.
Oh! Okay.
Okay, so this is the way, yeah, this is the way I had these problems. I explained how to do these problems, how I like to do these problems anyway. So what you have is here you're going to put f prime, g prime. And so here you have f of 3, and you have f prime of 3.
It's the product rule.
Yeah, that is a product rule. And then g, you're going to have -4, and you have -1. So what it's going to be is it's going to be this plus this. So here's your negative 4 times 3 divided by 2. So here's your negative 6 minus 7. So negative 6 minus 7 is negative 13. There's your answer. Okay, let us go to, so yeah, so Kylie's right, this is a product rule application. When you see a multiplication symbol, you should think that. Or if it just said FG, you should think that too. If you see a division bar, if you saw F divided by G, what should you think then? It has to be a quotient rule situation, right? And then you could find out what that is. Here, do that. Find F d dx or F over G prime. Find that from here. I don't think it's going to be a multiple choice answer. See if you can find that.
At x equals 3.
At x equals 3. Yeah, at x equals 3. At x equals 3. Okay, basically what I'm looking at is your low is going to be the G, right? So negative 4, the D low is equal to negative 1. The high is equal to 7. D high is equal to 3/2. So our answer to this is going to be low D high
This one? And this one.
minus high
Mine's high to low.
D low
So it'd be,
over low squared.
well, yeah.
So that's going to be 16. So here we're going to have negative 6. That's going to be negative 6 plus 7. So negative 6 plus 7. So you get 1/16 out of that. All right. Questions on that one? I don't know if you got the same thing. But yeah, so what we're trying to do with these little quiz things is keep some of these things at the forefronts of your mind. Is it easy to keep these things at the forefront of your mind? Probably not sometimes. Okay, here we go to note card 44, definite integral and the interpretation of definite integral. And
We don't have that.
Yeah, it's on the back of the paper that we turned in.
oh, is it? Yeah. Let me turn this back into you. That is right. Here, I have yours down here. This is yours. This is yours.
There we go.
Oh gosh.
Do you see yours at all on this one? You might have turned in that other one too. Let me get that printed out. This will be Hannah, do you have that one?
Yeah.
Okay. Hannah, you got to turn in that other, the front side of that as a home, as an assignment. You got to turn in. Let's see, 191.
I have this.
Yeah, it's going to be 2 columns in that. Okay. Here's the other side of that page. what I can use.
Where did that
Okay, this one right here introduces another notation that we haven't talked about in this class, but do you ever remember seeing this notation before? This sigma, we call the sigma notation, this thing right here, you remember that?
Looks mighty familiar.
Yeah, it should look familiar. It's been a while. We did this in pre-calculus last year. We did this right toward the end of the first semester, and one of the things we talked about, this is what this is. This is an infinite series, and basically what it's doing, it's taking the number you're dividing or separating these into an infinite number of rectangles, this thing here, delta x, and so when you approximate and use limits to have an infinitely great number of rectangles, it is the area that is under the curve. And so we've used this notation here, and it's going to be the notation that is more of the classical calculus notation, and we're going to use this more, but in case you see the sigma notation on the left, it's an infinite series and that separates. So what it is, if you take a Riemann sum and make these rectangles infinitesimally skinny and have an infinite number of them, that ends up being the same as the actual area. So conceptually, that's what it is. And then it says here, the domain with units, solution of the integral with units. And so we get to the only problem that is associated on this note card, which is this one right here. And so I want you to work this out. This is one where it says it's a calculator one, and it says using correct units explain. You actually, for what I need you to do on this one, you don't actually need to put a calculator to it, because I don't have to know the arithmetic of the answer. You can borrow one, but you won't need a calculator for it. You can borrow one.
Oh, we don't.
Here.
Oh, you don't need it?
Yeah, I'll say it again.
Yeah, you can put that bird back in your pocket.
Now let me say it again, okay? Even though this is a calculator problem from an actual AP test, I'm not going to need to have you require and do all the arithmetic that a calculator would be very helpful for.
Some people just don't listen, Mr. P.
I was listening, I just thought you maybe must write stuff down.
Yeah, he didn't process. He didn't process. That's fine.
Yeah. And
It's fine, Gavin. I'm okay with you on this one, Gavin.
Whose side do you want?
So here, have you done?
I've done it, yes.
Oh, you have done it.
I have.
I'm gonna start sleeping better.
Separate your intervals, your midpoints of your 5 subintervals of equal length. And while you're working that out, part B, we can talk about part B using correct units. What is the meaning of the integral? You have the velocity of the feet per second. What is the meaning of the integral? What is the meaning of the integral?
No, I put it in the sheet. What are the units going to be?
after you integrate this?
Oh,
Okay, Kylie says feet, is that right?
Yes.
How do you know it's right, Gavin?
I just remembered from the other day.
Okay. That's good. Anybody add to, that's fair. Any additional explanation besides Gavin's? How'd you get?
To seconds, so 8 feet.
Okay, so what it does, so Hannah's saying that we had feet per second, you take the integral of that, you're left with feet, right? Okay, that's a good explanation. Yeah, exactly right. So using correct units, what is the meaning of the integral? What is the meaning of the integral? You're going to have an answer that's going to be feet, we know that. What is the meaning of the integral? It has you give this verbal explanation up here, you have a table, and you figured out what the number is, you found your 5 subintervals, which I don't know what they are yet. 2, 3, 4, 5 feet. What is the meaning, when you have the numbers for that, what is the meaning of the integral?
wait. I don't think I understand the question. Like, what it represents?
Yeah, when you have this answer here, what is the meaning of that answer? What is the real world meaning of the answer? It gets back to P-Bang.
How many feet
Okay, how many feet?
the car travels on a straight road?
How many feet? How many feet? I'll agree with feet. The car traveled. And what else do you add to that? This looks right so far. How many feet the car traveled? Be nice to have a subject.
And you include the time?
Okay, what about seconds, Hannah, did you say?
Said, or how many feet the car
In 50
travels.
seconds?
And 50 seconds, right?
Listen to the song? You do? You know the song?
See, I didn't understand what it meant by that meaning.
Okay, that's how many. So when you have the answer, it's going to be the answer is going to be the answer to the question: how many feet the car traveled in 50 seconds? That's it. That's not that hard, is it?
I get it now.
Okay,
I
good.
didn't know what the phrase.
So let's go ahead and we have all these rectangles are what width?
10.
They are 10, right? Because you divide that, so 10, 10, 10, 10, 10. And what numbers will go in here?
5 times 12?
12,
Oh, okay. So it's
30.
12, 30, 70,
70,
81,
81,
and 60.
60, okay. Yeah, so if you're going to go ahead and, it looks like it's from the calculator portion of the test, but that's really not needed for the detail we need, right? Okay, good. Well, let's go on to our next, we're going to go to our next note card, which is
Wait a second.
45.
Okay.
Now we're going to the next note card.
Yeah, next note card 45. Note card 45 is what we call a technique of integration. It's called U-Substitution. And basically, U-Substitution rule is kind of analogous to the chain rule of differentiation, except it's a rule of, it's an integration rule. So basically what you're doing is, well, it gives you a list of things here to consider, and as usual, It's really best understood when you do what? Look at an actual problem. So let's go ahead and just talk about it briefly. Yeah, well, it's kind of hard to explain. We'll go ahead and do this. Basically, if you have something that is a little bit too complicated to solve in our standard way of integration, this is an integration technique that enables us to deal with a little bit of complexity, or a lot sometimes.
My bad.
So here, what you're doing is you could integrate this thing. Could you actually expand this thing out to the 8th power and multiply by 2x plus 3 and by 9 and integrate each one of those pieces? You can do that, right? How long is that going to take you to do?
A minute, a good while.
A good one.
To me, if I actually seriously did this without using a U-substitution rule, this would be an hour project for me
An hour?
to do this. Maybe not quite,
Is that a challenge?
but maybe not quite, maybe because I could do a binomial expansion, but then I'd have to multiply that binomial expansion with 9 terms by this, multiply by 9, and once I had it all expanded out, then the integration itself would be pretty easy. It's going to be the pre-stuff, right? And so what you're doing is you look for a situation where you're going to be able to cancel out. And so what I'm going to say is, I happen to notice something. You look for things here. Do you notice anything in common this x squared plus 3x plus 5 has with this 2x plus 3? What do you notice about these things?
Oh, I know what it is.
Okay, Aaron says he recognizes what it is. Do you know what it is? If you look at this x squared plus 3x plus 5 and this 2x plus 3, what relation do they bear to each other? That has to do with calculus. First semester calculus. Do you recognize it, Kylie?
Yes, I know what I'm doing, or I know
Carson,
how they
you-
correlate.
Do you recognize what's going on here,
Somebody don't
Carson?
work.
Gavin, you recognize it?
I know how they correlate.
Okay, how do they correlate?
I think she knows what it is, she just said.
Okay.
Like
2x plus
whenever-
3 is the derivative of x squared plus 3x plus 5.
Yes.
Yeah, so this is a first derivative of this.
Why did I just forget the word derivative? In my head, I was taking the
So-
derivative.
So what I'm going to do is the way to write this up, now it becomes a way of articulating, because once you see something is the derivative of something else, that means it's probably a good candidate for U-substitution to figure it out. Yes.
I go to relieve myself. I use the restroom.
I like relieving yourself better.
I think, is that disrespectful? I feel like it's kind of just, I don't know.
I don't know, it felt, I don't know.
Now everyone knows that you're going to relieve yourself.
Sorry, Mr. G.
Okay. I'll try to gather myself. Okay. So basically, we're going to let U equal this. So usually what it ends up being is the more complicated looking thing is what you let U be equal to. All right? So, and you take the first derivative of this, you say du dx is equal to, take the first derivative of this, and we get, what is our derivative of this? 2x plus 3. Okay, and then, so du, we cross multiply the dx, du is equal to 2x plus 3 times dx. Do you see that? Now, before we actually go and work this out, the next thing we're going to do is solve for dx. What is dx equal to? What is dx equal to? Carson, Hannah, what is dx equal to? Well, what is dx equal to? What do you do? You're solving for dx now. What do you get when you solve for dx?
So you just, like, this was also the -2 -3, -2.
What is this 2x plus 3 doing to this dx? Multiplying, right? So what do you have to do to solve for dx? So you're dividing by, so you have this. And you have to have something like this in order to cancel this out. So now you're ready to go ahead and reassemble this thing here. And I'm going to put this 9 right out here, park it on the outside. In here, we're going to have u to what power? Since that is u, this is going to be u to what power? 8. Then we're going to have 2x plus 3. And then we're going to substitute dx with du over 2x plus 3. What happens here? What did you cancel out here?
The 2x plus 3.
So these cancel out here. So what you're left with is 9 integral of u to the 8th power d, and this becomes du, right? Because you replaced with du over, I forgot to say du, so you replace this dx with du over 2x plus 3, so you have this left over. And so what is your answer for this now? 9 u to the,
No, not you, good math here. 9?
divided by 9 plus c. And so you have this. And how do you rewrite your final answer? You go back and replace it, right? U. So we have x squared plus 3x plus 5 to the 9th power plus c, and this will be your answer for that.
Whack.
Does that look that bad?
Might take a tad more practice, but
Yeah, it'll take practice, but that's where we are. We are doing practice on these things. So that's it. All right, what I want you to do is, let's look at this next problem here, see what this is. Yeah, so we get to some classwork here on this, and it sort of gives a snapshot of how to do that. Well, here, what you're going to do is you take this thing right here. You can say, for 1, what would you let u equal?
x squared minus 1.
So this one here, u, I'm going to get a skinnier pen here because I'm going to run out of room. I don't know what your room looks like. So u equals x squared minus 1. So what does du look like? What does du dx look like?
2x.
Is 2x. So where are your packets?
Okay.
Why? Okay, class is still in session. Okay. So here we have x, and then we have du is equal to, if we multiply this here, we get du is equal to 2x dx. And what is dx equal to? Du over 2x. So here we can rewrite this thing as x times u to the power of 5, and substituting dx with du over 2x, what do we have left here? X over x. So I'm just going to bring this down here. We have 1/2 integral of u to the 5th du. And what is this going to be here? One half u to the 6, good job. And we're going to divide by 6, right? And that's going to be plus c. So we're going to get, is that going to be 1/12?
Yep.
1/12. And we can substitute back in now, can't we? X squared minus 1 to the 6th power plus c. And so that's going to be our answer. Does that look like that's very hard?
I think I get it.
Yeah, so it's a matter of practice. So what I plan to do tomorrow, what we plan to do is just kind of go through some of these things and get going on that. Okay, questions on that?
No.
All right.